electrons equals 96,485 coulombs. Charge. We need this other conversion factor. That is the current. The current is in amps. 1 amp is defined as 1 coulomb of charge passing by 1 second. And so the amount of charge is the current times the time. In other words, this equation is a little, these are the two equations I would remember. One amp is defined as 1 coulomb of charge per second. And then we know Faraday's constant. Therefore, if we know the amps, you know what the current is, and time, then we can calculate how many moles of electrons have passed through the circuit. How many moles of electrons? So that's what this equation is trying to show, is the moles of electrons is going to equal the current, amps, times time, which gives us coulombs. And the coulombs we convert into moles by using the Faraday constant. And this equation we don't have to memorize, we just do it using dimensional analysis. Easy enough. Dimensional analysis. So let's go back to this cell. This cell, let's say, a typical question would be like this. If I run this, let's say I have 30 minutes of reaction. And then a current. The current, it doesn't have to be an electrolytic cell, it could just be a battery. The battery is going to have some current to it. And let's say this was running at 1.01 amps, which is pretty high. You know, in physics they say it's not the voltage that kills you, it's the current. You know, if you get a lot of current running through your body, you can die. But you can be exposed. I've been shocked by 15,000 volts, but I didn't die because it was very little current. Whereas, you know, if you have 12 volts with 1 amp of current, that can melt. You know, that can melt a screwdriver or something. It's a lot of current. Well, anyway, let's say 30 minutes of 1.1 amps, and so we just use dimensional analysis. 30 minutes of reaction at 1 point. So this is 1.01 coulombs of charge per second, and then we know that 1 mole of electrons is 96,485 coulombs, according to Faraday. And so this tells us how many moles of electrons. And so, for example, if I wanted to figure out how much chlorine is produced, then I know that 1 mole of chlorine is produced for every 2 moles of electrons. This is from the balanced half reaction. The balanced half reaction is this. You know, 2 chlorides produce the chlorine plus 2 electrons. So we see 2 moles of electrons for 1 mole of chlorine. And then we can figure out how many grams. This tells us, you know, there's what, 70 grams per mole, 70.90 grams per mole of chlorine. So I can figure out how many grams of chlorine. Or, likewise, I can figure out how many grams of hydrogen, because the hydrogen would be a mole of hydrogen for every 2 moles of electrons transferred. And then hydrogen is 2.02 grams per mole. So I could do something like that. And so we could do stoichiometry in these cells as long as we know the current and the time. Okay, any questions on this? That's pretty much the last section of chapter 20. And so what we have left This is their little thing we put there. Some advice from Petrucci. This is good. This is good advice. But we have chapter 24, the last half, and 25. 25 is nuclear chem, so it's going to just be a brief survey of nuclear chem. Nuclear chem plays by different rules. You know, chemistry plays by electrical attractions and repulsions. Nuclear chem is a little different. So just a survey of nuclear chem. And then the last part of complexes. All right, today we're going to do a lab, though. This will be our last wet lab. We're going to do electrochem. So you'll need goggles for this lab.